Have you ever looked at a solar panel and wondered how a simple sheet of glass can turn sunlight into electricity? There are no moving parts, no fuel, and almost no noise. Yet, when sunlight hits the panel, electrical power is produced. In this video, I'll show you exactly how solar panels generate electricity, step by step, in a simple way that anyone can understand. And stay until the end, because I'll also show you a simple calculation to estimate how much energy a solar panel can produce in one day. The basic idea behind solar power is surprisingly simple. A solar panel does not collect or store sunlight. Instead, it converts the energy in sunlight directly into electrical energy. Sunlight hits the solar cells, the energy from that light causes electrons inside the cells to move, and this movement creates direct current, or DC electricity. Then, an inverter converts that DC electricity into AC electricity that we can use in our homes. So remember this simple chain: sunlight, solar cell, DC electricity, inverter, and finally usable AC power. But how can sunlight actually make electrons move? That's what happens inside the solar cell, and we'll look at that next. The process happening inside a solar cell is called the photovoltaic effect. Sunlight contains tiny packets of energy called photons. When these photons hit the silicon material inside a solar cell, they transfer some of their energy to electrons. This extra energy allows some electrons to move. Because of the special structure of the solar cell, an internal electric field pushes these electrons in a specific direction. When we connect an electrical circuit, these moving electrons create electric current. So, in simple terms, photons come in, electrons start moving, and electricity is produced. That is the photovoltaic effect. Panels combine many cells. One solar cell by itself produces only a small amount of voltage and power. That's why a solar panel contains many individual solar cells connected together. When cells are connected in series, their voltages add together. When the complete panel is connected to a load or solar system, current can flow through the circuit. And electrical power depends on both voltage and current. Remember this important relationship. Power equals voltage multiplied by current. So, by combining many solar cells, we can produce useful levels of voltage and power. But there is one important problem: the electricity coming directly from the panel is not normally the same type of electricity your home uses. Solar panels naturally produce DC electricity, or direct current. Direct current means that electricity flows mainly in one direction. This is also why solar panels work well with batteries, because batteries store and supply DC electricity. In an off-grid or battery-based solar system, a charge controller is normally placed between the panels and the batteries to control the charging process. However, most household appliances operate using AC, or alternating current. So how do we turn solar DC power into the AC power our homes need? For that, we use an inverter. The inverter is one of the most important devices in a solar power system. Its main job is to convert the DC electricity produced by the solar panels into AC electricity. That AC power can then be sent through the electrical distribution system and used by loads such as lights, televisions, fans, refrigerators, and other appliances. Modern solar inverters can do much more than simple DC to AC conversion. Many also use maximum power point tracking, or MPPT, to help extract as much available power as possible from the solar panels. They also provide important monitoring and protection functions. So you can think of the solar panels as the power producers and the inverter as the device that makes that power practical for everyday use. But even with the best inverter, your panels will not produce the same amount of electricity all day. Several important factors affect their output. The amount of power produced by a solar panel constantly changes. The first and most obvious factor is sunlight intensity. Stronger sunlight usually allows the panel to produce more current and therefore more power. The angle and orientation of the panel are also very important because they determine how much sunlight reaches the panel surface. Shading is another major factor. Even partial shade can significantly reduce the output of a solar array, depending on the system design. Temperature also matters. Many people think hotter panels produce more electricity, but actually, very high cell temperatures usually reduce panel efficiency. And finally, dust and dirt can block some sunlight from reaching the cells. So remember this simple rule. Good sunlight, correct installation, minimal shading, and clean panels mean better solar production. Now let's look at a simple example. Imagine we have one solar panel rated at 550 watts. If we assume the panel receives the equivalent of 5 peak sun hours per day, we can estimate the energy production by multiplying power by time. So, 550 watts multiplied by 5 hours equals 2750 watt-hours. That is equal to approximately 2.75 kilowatt-hours of energy per day. But remember, this is only a simple theoretical estimate. Real solar production depends on factors such as weather, temperature, panel angle, shading, dirt, wiring losses, and inverter efficiency. Still, for a quick estimate, remember this formula. Energy equals power multiplied by time. Now we can put everything together and explain the entire solar power process in just a few seconds. Let's summarize. First, sunlight hits the solar cells. Second, the energy from sunlight causes electrons to move, producing DC electricity. Third, the inverter converts that DC electricity into AC electricity. And finally, that AC electricity can be used to power your home and electrical appliances. That's how solar panels turn sunlight into useful electrical energy. If this video helped you understand solar power, give it a like and subscribe to the channel for more simple and practical solar energy lessons. And in the next video, we'll answer another important question. Should solar panels be connected in series or in parallel? Subscribe so you don't miss it, and I'll see you in the next video.